Tonight, the beekeeping industry is in crisis over the shocking and hundreds of millions of bees over the last 8 months.
In 2023, researchers did something that sounds completely unhinged. They took millions of bees, froze them nearly solid for weeks, and released them into the Sahara, a place where the sand alone can hit 160 degrees Fahrenheit. No shelter, no flowers, no water for miles. Then they walked away and left them there for an entire year.
And we actually know it's an amazing biodiverse place and that insects are the cornerstone of those ecosystems.
Everyone assumed they'd return to nothing, a desert that had quietly swallowed the whole experiment. Instead, the monitoring data stopped the scientists cold because the bees hadn't just survived the impossible. They'd revealed something about the desert no one was supposed to find. The collapse spiral. Because what they did sounds like a fever dream. They took millions of bees, froze them nearly solid for weeks, and dropped them straight into the most hostile desert on Earth. And the math made it sound impossible too. Bees start dying when hive temperatures cross around 40 degrees Celsius, and Saharan summers regularly push close to 50 in the shade. So, why send them in at all? When the first colonies were released near the oases, the researchers expected heat to be the killer. It wasn't. The real enemy was silence. No flowers, no steady pollen, no food network to plug into. A healthy colony can need millions of flower visits in a single year just to function. And across much of the Sahara, after a few weeks of hot wind, the thin band of green clinging to an oasis can nearly vanish. And when it does, a loop starts that is almost impossible to stop. Fewer plants mean fewer bees. Fewer bees mean less pollination. Less pollination means fewer seeds. Fewer seeds mean fewer plants next season. Scientists call it a pollination collapse spiral. And the frightening part is that it never announces itself. A field still looks green, an oasis still holds water. But underneath, the insects and seeds and pollen keep quietly dropping year after year, until one season there just isn't enough left to come back. And this was never only a Sahara problem. It's already happening in places you'd never expect. A global problem.
When I first arrived in the Sahara, I was just struck by how utterly barren it was. It's like the color green was removed from the palette when they made this place. Just nothing, grays and browns, and not a scrap.
Roughly 75% of the world's food crops depend at least partly on pollinators. California alone needs more than 2 million bee colonies every single year just to keep its almond industry running, not thriving, running. And in the winter of 2024 to 2025, beekeepers across the United States reported losing around 60% of their colonies in a single season. 60% in one winter. In parts of Western China, it has already gone further. Wild bees there have collapsed so badly that farmers now pollinate pear and apple trees by hand. Small brushes climbing through the branches, doing the work insects used to do for free. Humans with paintbrushes, standing in for bees. That isn't a warning about the future, that's right now. Which is why an experiment in the deadliest desert on the planet suddenly mattered far more than anyone planned. And if these are the kinds of stories you want more of, the quiet ones that rearrange how the whole picture fits together, hit subscribe, because what happened next is where it stops being about bees at all. The perfect stress test. What the team was really watching wasn't whether bees could tough out the heat. They were watching what happens to an entire ecosystem when its pollination layer collapses in real time. And the Sahara, strangely, is the perfect place to watch it. If ecosystem collapse has a worst-case version, this is it. No buffer, no backup, no margin for error, which is exactly why what came next made no sense at first. Some of those colonies didn't collapse, they held on. And they were not the ones anyone would have bet on. The night shift.
Saving the bees, an effort underway to help these pollinators. Mary Jan Bayesa explains what Assembly Bill 221 would do and the role bees play in southern Nevada.
Picture that researcher again, months into the experiment, hunched over the monitoring feeds at the oasis. The colonies still alive are doing something that shouldn't be possible, and it takes a while to even believe the data. What stopped them cold was simpler than anyone guessed. The surviving bees hadn't changed their bodies, they had changed their schedule. In the colonies that lasted, peak activity happened before sunrise. Flight almost completely stopped at midday. Then they came back out in the late afternoon, into the evening, sometimes even after dark. They stopped fighting the sun. They started working around it. And if that sounds familiar, it should. Nearly every animal that survives the desert does the same thing. Fennec foxes hunt at night. Scorpions bury themselves. Through the day, desert gazelles barely move when the sun is highest. They don't beat the heat. They avoid the hours it lives in. But bees are daytime insects. That's supposed to be part of what they are. The thermal cameras near the oasis zones in Algeria laid it out. Sand surface temperatures topping 65 to 70 degrees Celsius during the day. A few hours after sunset, that same ground dropped by more than 25 degrees. That window, 2, maybe 3 hours between the sand cooling and the night going fully dark, is when life moves. That's the survival window, and the plants already knew it. Some desert flowers had started opening later, holding their pollen longer, releasing stronger scent after dark, basically advertising that the shop was open at night. The bees and the flowers had landed on the same schedule with no coordination at all. 2 organisms, same problem, same answer. Then, a recent review of arid ecosystem data found nocturnal pollinators play a significant role in nearly 90% of dry ecosystems studied. 90%. And most of it happens while we are asleep. We've studied deserts for decades, cameras, samples, papers, and we did almost all of it in daylight, which means we may have been missing half the story this whole time. But the schedule wasn't even the strangest thing in the data. The small ones. When the researchers finally lined up which colonies were still standing, the pattern broke every assumption they had walked in with. There's a particular kind of stillness that hits when the data contradicts everything you expected. And out there at the oasis, that's exactly what landed. The colonies that lasted longest weren't the biggest, not the most productive, not the fiercest defenders of the hive. They were the small ones, scattered, quiet, less honey, less of everything we'd normally call success. On paper, the weak ones. But in the Sahara, being optimized was a liability. Think about what a big colony actually needs. More water, more flowers, more energy, just to keep the hive cool enough to work. When heat drags on for weeks, those demands don't shrink. They pile up. The hungriest colonies collapsed first. The small ones, barely consuming, asking almost nothing from a place that had almost nothing to give, were the ones still alive months later. That is how desert ecosystems have run for thousands of years. Low consumption, no excess. Every calorie spent only when it has to be. And that should make us deeply uncomfortable, because we have spent decades building bees to do the exact opposite. What we did to them might be the reason they are dying now. Built to break. For decades, commercial bees have been bred for maximum output, gentler temperament, higher honey yield, easier to manage at scale, the perfect agricultural bee. And in building it, we may have quietly stripped out the one trait that keeps a colony alive when conditions turn brutal. The Varroa mite is the clearest example. It's a parasite that latches onto bees, weakens them, and spreads viruses through an entire colony. It has been gutting commercial operations for years, feeding directly into colony collapse across North America, Europe, and parts of Asia. Most commercial colonies today can't survive a Varroa infestation without us, without treatments, without management. Pull the beekeeper out, and many of those hives don't make it through the season. Now compare that to certain wild African bee populations, less domesticated, harder to handle, far less optimized. They've shown real resistance to the same parasite, not immunity, resilience, the kind that doesn't need a human intervention schedule. The thing that survives longest isn't the thing built to perform best when conditions are perfect. It's the thing that still works when they're not, which is the moment this stopped being a story about bees and started being a story about us. But none of it answered the question everyone actually wanted answered. After a full year out there, did any of it work? 1 year later, after nearly a year, the Sahara did not turn green. No wildflower carpet across the dunes, no rivers in the sand, no before and after photo that breaks the internet. And honestly, that was always the realistic outcome. Bees don't make water, they don't build soil. What they do, what they've always done, is stabilize whatever life is already trying to hang on. They make fragile things a little less fragile. That's the whole job. So, what did a year of watching actually show? At several oasis sites, native trees set more fruit. Some wild desert flowers bloomed longer than they should have. Small insect populations around the water ticked up. Nothing dramatic, nothing headline-worthy on its own, but enough to prove that even in one of the most depleted ecosystems on Earth, a working pollinator chain can still send a ripple outward. And that small, unglamorous result is exactly where humans tend to make their biggest mistake. The scaling trap. The second we see any success, green shoots, a good data point, the instinct kicks in to scale it up. More bees, more trees, bigger projects, faster timelines. Turn a small proof of concept into a continental rescue mission. It feels like the obvious move. It has been the wrong move over and over for decades. Across North Africa and the Middle East, there's a long graveyard of desert greening projects that started with good intentions and ended badly. Some massive tree planting schemes in arid zones drained underground water so hard that they sped up the desertification they were meant to reverse. Others brought in non-native species that wrecked the soil's salinity, leaving the ground harder for anything to grow, including the native plants that had quietly survived there for centuries. The land didn't need rescuing. It needed to be left alone to do what it already knew how to do, which leads straight into the most unsettling realization of the entire experiment, one that has nothing to do with bees at all. Never broken. Maybe the biggest result of the whole year wasn't about bees. It was the reminder that ecosystems don't need us to fix them. They need us to stop assuming that fixing them means making them look like somewhere else. The desert was never broken. It was just being the desert. And that gap between broken and different turns out to be everything. We walked into the Sahara certain it was empty, too hot and too dry and too lifeless to matter, unless we turned it into something else. But the experiment didn't repair the Sahara. It revealed we'd been misreading it the whole time, and the proof was sitting thousands of miles away, somewhere you would never think to connect to a desert. Feeding the Amazon. Every year, hundreds of millions of tons of dust lift off North Africa and ride the wind west across the Atlantic. Some settles in the Caribbean, some keeps going. Tens of millions of tons eventually fall over the Amazon rainforest, carrying phosphorus, one of the most critical nutrients tropical trees need to grow. Think about that. Part of the Amazon, one of the most alive places on the planet, is being fed by the Sahara, by the place we fly over and write off as wasteland. The desert that looks most dead is quietly feeding the forest that looks most alive. And once you see it, the pattern is everywhere. Small bees holding a food chain together, night insects pollinating while everyone sleeps, one oasis anchoring an ecosystem across hundreds of square kilometers, desert dust crossing an ocean to feed a rainforest. None of it photographs well, none of it goes viral. But pull any single piece and something downstream falls apart. That's what the experiment quietly proved. Not that bees can save the Sahara, not that we can reverse desertification, but that the places we write off as worthless are often doing something invisible and irreplaceable, and we only notice when it stops. We measure a place by how much it looks like somewhere we already approve of. Green, lush, productive. The Sahara fails every one of those tests. And maybe the most honest thing this experiment gave us wasn't data. It was a better question. Not how do we fix this place, but what is it already doing that we never noticed? So much of what nature does just happens at night, underground, or across distances too vast for us to track. The bees didn't transform the desert, but a year of watching them try changed how we see it. If this rearranged something for you, subscribe. There are more of these coming, and then tell me. Drop the one place you think we've completely misjudged in the comments.